Hi, I'm Kevin Wilamowski, Senior Outbound Product Manager in the Telecom, Media, and Technology Business Unit at ServiceNow. Today, I'd like to take you through an overview and demonstration of the features we are releasing for the Telecommunications Network Inventory product effective the Washington, DC release. Let's dive in. Most of the content that we look at today exists as of the Washington, DC release. But if we go over any forward-looking information, any product features that are not currently in the product, we definitely encourage you to only make purchasing decisions based on what is currently available now in the product. So an overview of the new features and enhancements for Telecom Network Inventory in the Washington, DC release. We've got planned revisions, the ability to create future versions of existing network designs. We are introducing capacity management, so a new plugin that installs with Telecom Network Inventory Advanced that allows you to manage the capacity associated with your cards, slots, ports, and equipment. Topology Visualization is now available in Network Inventory, so the ability to create network topologies and then a UI specifically to render those topologies. We've also introduced rack management capability, a UI that shows the front and back of equipment racks with the ability to drill into those racks to get additional detail on the equipment that's mounted there. Channelized Bandwidth is new with the feature with the Washington DC release. This is the ability to create logical connections that have channelized logical connections associated with them. We'll go into the use cases for that. We are introducing a new data model to support our ability to manage fiber cables and fiber strands. And then we'll wrap up with a workspace re-architecture of the network inventory workspace and some of the updates that we've made to that workspace. So starting with planned revisions. Planned revisions allows TNI users to create future versions of existing network equipment or connections. So often when you are planning and building your network, you're evolving that over a period of time. You may need to take a look at existing network connections today and know that tomorrow those need to change where they're going. So planned revisions provides the ability of users of TNI to create clone versions of existing designs, make changes to those designs, and then promote those changes to live in the future versions. Let's take a look at how that works. In the Washington, DC version of Telecom Network Inventory, we are introducing a new feature called Planned Revisions. Planned Revisions allows users of TNI to take existing network designs, make changes to those designs that are going to reflect a future design. What we'll do is we'll go to our change models. We'll do a new change request. So Planned Revisions doesn't come with an out-of-the-box change flow, because the types of things that you'll do for planned revisions are going to be a lot of different types of things, and there's no way to pull those together into one change flow. So the way you'll do that is to create a normal change request, and then we'll just add the tasks associated with this revision. So I've opened my new change request. I'm going to go to my tasks, and I'll do a new task. And the one I'll choose is called Revise CI. Revise CI is going to take that circuit path and make a copy of it, and then all the changes will be done to the copy of this. So let's go ahead and add a quick description, and we'll save that. So now we'll add one more task here. And the task type is called Operationalize CI. So when we operationalize, what's going to happen is all of the changes that were made to the duplicate CI or the clone CI are then going to be taken and applied to our original live version. And so that's the operationalizing of those changes. So let me finish adding my descriptions, and we'll save that. So now I've got my change request for my planned revision. I have both of my tasks, one to revise and one to operationalize the CI. So here is my circuit that I want to make changes to. If I look at my connection elements, I will see that right now this circuit consists of two things, two logical connections. Each of these logical connections are 10 gigabits each. And in this example, I want to add another 10 gigabit connection here to bump this capacity from a 20 gig to 30 gig. So to do that, let's go ahead and get a copy of this name, because we're going to go back into our tasks. And so I'm going to give it the CI that I want to make changes to. And when we do that and submit, you'll see that it is now updated successfully. And if we open it, you will see that it's now got a V1 for version 1 attached to it. So it's the same circuit that we looked at originally. This is just a clone of it, and it's identified by this version 1. So now what I can do is I can go back into my connection elements, and I will add that capacity. So I'm going to add a logical connection. I know the logical connection that I want because I built this prior to going into my revisions. So this 103, I'm going to add. And sequence and route, on this one, I'm going to keep this as a sequence 1. So all three of these are going to be the same sequence. And in this case, the third will be route 3. So we'll save that. And now when we go and we look at our version 1, we could see that we've got 3 connection elements now showing. So now I've made my changes, so that all looks good. I can go ahead and close this. So now we'll go back to our change request and we'll operationalize those changes. So if we click on our other task here, you'll see that I can either put in that CI name that I did on the other task, or what I can do is just put in the change request number, and then all of the things that that were made, that had changes made to them, will then be operationalized. So in this case, let's go ahead and just use the whole change request. All right, so now when we submit, it's now automatically closed. And if I take a look at my version 1, it was in design and build as for my status. If we reload that, we'll see now that it's been changed to put to end of life and retired. All right, so and if we go look at our original circuit path, you'll see I've got my connection elements here. And if we refresh that, you'll see that now my original existing path has now been successfully revised, and I've added my capacity. So that is how planned revisions work in our Telecom Network Inventory Washington DC release. Thank you very much. Capacity management has been introduced with the Telecom Network Inventory Washington release. So a framework now ships with the product. There's a plugin that gets installed when you install Network Inventory Advanced. That plugin has some tables associated with that allow you to define what it is you want to measure capacity on. Allows you to create the functions associated with calculating those capacity measurements. And then a metrics table, which allows you to see all of the items in your network that have had capacity measured against them. Telecom Network Inventory for the Washington, DC release is introducing a capacity management framework for network inventory. Let's dive into that and see what that consists of. In the Washington DC version of TNI, when you install Network Inventory Advanced, it will automatically install a capacity management plugin. That plugin contains 3 tables that are used to manage network capacity in TNI. Those tables are definition, functions, and metrics. Let's take a look at each. The definition table is where you would define what it is that's being managed for capacity. So you can see that out of box, we've included several different measurements. We've got port capacity available on cards. We've got slot capacity available for cards. We've got both port and slot capability or capacity for equipment, overall network port availability, and then we have a couple rack capacity measurements and slot and subslot availability. If we take a look at the capacity for slots and cards, you'll see that we have a definition. This defines the slot capacity functions for the card entity. We've got functions associated with this. I'll go into the functions in a second, but essentially these are where you define how you're going to measure capacity. So in this case, the functions being used for this definition are card max slots and card occupied slots. I can also set filter criteria to define specific measurements. So in this case, where I'm measuring total slot capacity for cards on any given device, I can actually go in and create a rule to measure capacity for maybe just a particular vendor. So I want to measure capacity associated with all of my Cisco cards. I can do that. So these are definitions for capacity management. The next area we'll look at are the functions. Now, as I said, functions are where you define the logic used to measure the capacity. So keeping with our card slot functions, let's take a look at that. So when we go into the functions, let's edit this record. The first thing that we'll see is this function here. If we click that, there are 3 different choices to choose from. The first is max, second is occupied, third is available. So basically this is defining what type of calculation do you want to create. In this case, it's going to show me the maximum number of slots available, but I could also select just show me the total occupied slots and then show me total available slots. In this particular one, we're just choosing the max slots. And then the strategy, there's several strategies that you could use. And the strategy is where you define the reference value that's going to be used in your capacity measurement. So the choices I have here, static value is if you have just a fixed value associated with a device that you want to use in your calculation. So I just want to plug in the number 12 because I know 12 is the number of slots. I can actually do an aggregate query count. This allows me to choose a table that I can go run a query on to determine the value that I want to measure the capacity against. I can choose a value field where if I select that, it allows me to just choose a table and select an attribute from that table. So if I want to say select the equipment model table and then total rack units available, I can select the value from that just by using the value find. And then the last one we have here is script, and that's the one that we're currently using for calculating the card max slot capacity. And a script will allow you to obviously create a script to further define the criteria and how you want to measure the capacity. So now let's take a look at our metrics table. The metrics table includes the measurements that have been calculated associated with all of the items in your network inventory that have had a capacity measured against it. So in this case, let's go look at equipment slot capacity. We'll show those. And then specifically, let's go look at this particular CI. So we saw that the functions used in calculating the slot capacity for cards were the max available and the max occupied. But you can see that there are 4 different values here. And what happens is whenever you provide the values for what the maximum was and what the occupied is, it will automatically create the calculations for what's available and then the percentage of usage associated with it. So if we go back into Network Inventory Workspace, we can see on our inventory management page some of the widgets that are utilizing these capacity measurements. So I've got my rack availability showing me racks with available units. So it's calculating those rack unit availability as well as maximum contiguous units, and slot availability and port availability. So this is an overview of the capacity management plugin that is part of Network Inventory Washington DC release. Thank you very much. The Topology Visualization UI is new with the Washington DC release of TNI. This allows users to render topological network views on a canvas, one or more of those views, so that you can see how they interact with each other. Let's take a look at what that feature looks like. The Network Topology Viewer is new in the Washington DC release of TNI. Let's take a look. So in Network Inventory Workspace, I'm going to navigate to a new menu item on the left-hand side, which is called Network Viewer. When we click on Network Viewer, that's going to bring us to a canvas where we will be able to select different network topologies to render and to look at. So I'm going to go take a look at my network topologies. I'm going to filter for a couple here. Let's take a look at this mesh topology. So what will happen is I'll select the topology. When you create a topology is really just a logical collection of network sites, network devices, and network connections. So in this case, I've got a topology of a mesh type of network. So I've got various network nodes that are interconnected. And if I click on any one of these nodes, it will animate the connection line showing the connections from that node to all the other nodes. I can click on this information button on the right hand side and get access to information about the equipment at these nodes just by clicking on this device, or I can get information on the logical connections between these devices and nodes by clicking directly on the pill. I can also go in and show multiple topologies to see how they interact with each other. So in this case, I want to take a look at a tree topology and how it interacts with my mesh topology. So in this case, I can see I've got 3 nodes, of which there are multiple nodes coming off each of those 3. So if I click again on any of those nodes, you'll see the animated connections of the lines that connect from that node to other devices. I can obviously move these around and resize and reshape as needed. And then after that, I can also just reset everything to normal. I can reset it and fit everything to the screen. So this is a view of the network topology user interface, new for TNI in the Washington DC release. The Rack Management UI is new with the Telecom Network Inventory Washington release. This capability allows users to visually see their equipment racks and the equipment rack units associated with those racks, whether those rack units have equipment installed with them, or whether those rack units are reserved for other users, or whether they're available. In the Washington DC release of TNI, we've introduced a new equipment rack visualization user interface. Let's take a look at it. So what I'm going to do is I'm in Network Inventory Workspace. I'm going to navigate to my Equipment Holders class. So if we click on Equipment Holders, that's going to take us to all of our equipment holders. And specifically, we want to filter for just the equipment racks. So we'll go search for class equals equipment rack. All right, now I have a list of all of my equipment racks, and the one in particular I'm interested in is this demo rack 48.1. Let's click on that. So now we go into our equipment rack user interface, and we'll start off with the visual representation of the rack. The default view is for both the front and rear view of these racks, although I can, if I want to, select just the front or just the rear. But the default is both sides. So I can see this is an equipment rack that has been created with 48 rack units in it. And then within those rack units, I can see where there's equipment mounted. So in this case, I can see an ASR 9006 is occupying rack units 45 through 48. It's got a status of operational. If wanted, I can click on that and get additional information on this card right here. So things like asset information, expiration of the warranty, the serial number, maybe the support group or the name of the individual or team that's responsible for this device. And then if I need to, I can actually drill into this particular piece of equipment and make changes. So if we scroll down a bit, we can see that these rack units default to available, but you can actually go in and reserve them. So a lot of times that's useful. So if you're planning to install new equipment at a site, a lot of times in advance of that, you'll want to go and make sure that you've got your rack units saved or reserved for you. So you can do that as well. You can install equipment so that it's just on the front or just on the rear. So you can show the equipment. If it's mounted just on the front, it will show that. If it's mounted just on the back, it will show that. So in this case, I've got a device that's occupying the front rack units 20 and 21. But on the rear side of that rack, I can see I've got different equipment that's in 20 and then nothing in 21 and something else in 22. Part of the equipment holder class includes something called a shelf. So you can actually instantiate an equipment holder shelf inside the equipment holder rack, and then you can relate equipment to that shelf. So in this case, I've got a shelf, but on that shelf, I have two devices resting. So I've got two RU devices that are shown resting on this particular shelf. So in addition to the rack visualization, you also have some widgets here. The top one showing the rack utilization percentage, as well as the maximum available contiguous rack units. So in this case, in this rack, I've got a maximum of 9 that are all together, and a total of 19 out of 42 that are being used. If there are any change requests or change tasks associated with equipment being installed in this rack, the quantity would be located here, and you could click into those as well. And then finally, I've got an equipment view that shows the quantity and the type of equipment that's located in this equipment rack. So this is a view of the equipment rack user interface that's new with the TNI Washington DC release. Channelized bandwidths are new with the Telecom Network Inventory Washington DC release. Bandwidth channelization is used in a couple different areas. Primarily, it's used right now for broadband fiber providers. And we use channelized logical connections to allow those users to create network connections that have multiple lambdas or wavelengths on them. So you could create one logical connection and have any number of child logical connections associated with that logical connection, and those child logical connections can be individual lambdas. Let's take a look at what that looks like. Channelized bandwidths for logical connections is a feature that's been introduced for Telecom Network Inventory in the Washington, D.C. release. Channelized bandwidths are used in a couple different scenarios. The primary scenario would be for a broadband fiber provider to model logical connections for their DWDM network. So you have network connections that have multiple wavelengths of fiber optic signals going over one circuit. And logical connection channelization is used to allow each of those wavelengths its own logical connection as part of that parent logical connection. So you could have one fiber circuit that has 8 different wavelengths going over it. And that's done through logical connection channelization. Let's see how we do that. So if we go into our logical connection models, we're going to create 2 different logical connection models. The first we're going to call this optical multiplexer section. So this is a logical connection model that's going to be used to represent the circuit that will carry the channelized bandwidths. So you can see my model category is set to logical connection. If I scroll down, I can see that there is a behavior field here that is set to connection. If I look at that, you'll see that there's two choices. The first is connection, the second is channel. We're going to use the channel connection, the channel behavior to define our channelized logical connections in just a second. And then we also need a reference to our logical interface model, and that's been done here. That's our optical channel interface. We'll take a look at that in a second. So here's our optical channel model. This is the model that's going to be used to represent the channelized individual wavelengths on that logical connection circuit. So again, our model category is logical connection. And if we scroll down, we can see that this time the behavior is set to channel. And the logical interface model referenced here is our optical channel interface. And so let's go up and take a look at our optical channel interface. So this is a network interface model, different from the logical connection models. So this is going to be a model for our ports associated, or actually not the ports because these are virtual interfaces. So it would be a virtual network interface. And when we're setting this, this optical channel interface, anytime you're setting the channelization on the model, you need to, or on the interface model, you need to set this flag to virtual. And then you can say the port bandwidth for this particular one is going to be 1 lambda. And so we've got the three models that are used to create these logical connection channelized circuits. The one thing that we're going to do to tie them together is we're going to create these network model relationships. So you can see that on my logical connection model for my circuit, I've got two different relationships. I've got one relationship that was created that's going to assign 48 child lambdas to the circuit. And then I've got another relationship that was created for this circuit that's only going to create 8 lambdas, or 8 channels, each for a lambda or a wavelength. So if we drill into the 8 lambda relationship here, you can see that my parent bandwidth is going to be 8 lambdas. My child bandwidth is 1 lambda. And it's referencing my optical multiplexer section model, and it's also referencing my child product model, my channelized logical connection for my optical channels. So if we go back and take a look at some of the circuits that were created using these models, they were done using this template. So I went and I created a 8 lambda OMS template. This is a template that's going to be used when we create a logical connection that has 8 lambdas, 8 child channels, 1 for each lambda. And I can see that the related templates associated with this are 8, it goes from 0 to 7, and each of these represents a channel on this circuit. So let's take a look at one of these logical connections that were created using these models and template. So I can see I've got my logical connection, and more importantly, I can see that if I look at my infrastructure relationships here, I've got 1, 2, 3, 4, 5, 6, 7, 8 child channels. And each of these channels is associated with a wavelength. Now, the naming conventions for logical connection channels is pretty standard. It's out of the box. But you can implement logic for your naming so that your channels have some indication as to the particular wavelength associated with that channel, like we've done here. So that's a quick review of logical connection channelization, a new feature from TNI in the Washington DC release. With TNI's Washington release, we've updated the data model to include some additional tables that'll allow users to better manage their fiber cables and fiber strands. The Washington DC release of Telecom Network Inventory has introduced several new classes to the CMDB to support an updated version of our ability to model fiber optic cables and fiber strands. Let's take a look at the classes that were added, and then we'll go into TNI and see how this looks. Starting on the right-hand side, we introduced two model classes, both descending from Enterprise Good Model and then originally from Product Model. So we've got a cable model that was introduced and is available out of the box, as well as a strand model. Extending from the hardware class, we created a new class called connection medium, and the attributes associated with this class will allow the user to stipulate the equipment on either end that this cable will connect to, or the network site or the interface associated with that site, as well as the connector type on it. And then a couple attributes for the length and the unit of measurement of length. From the connection medium class, we created two classes called strand and cable. These are more generic classes for strands and for cables. And then from an industry-specific perspective, we extended optical fiber cable from cable class and optical fiber strand from the strand class. And these two classes are the ones that will be utilized by TNI to store information about fiber cables and fiber strands. The use case that we'll go through today is based on a pretty simple view of three network sites. There are two fiber optic cables connecting these three sites. So I have one cable that's connecting our Fresno site to a site called Lemoore. That cable has some number of fiber strands associated with it. And then from the Lemoore site to the Hanford site, I have a second cable that also has some fiber strands associated with it. We go into TNI and take a look at what these cables look like and then the strands in them. We will see that in our network inventory workspace, we have a class called strands, which will show you all of the fiber strands associated with cables in your network, and then another class that lists your cables. So if we look from a cable perspective, we can go into this LH01 cable. This will show me the sites between which this cable runs. And more importantly, it'll show me on this related list tab, I've got two strands. I can also see those strands showing up in the CI relationships panel here. But if we go look at those strands, we'll click on that, and that will show me that I've got strands 3 and 4 showing associated with this cable. The A side termination is actually to another strand from another cable. So strands 1 and 2 on that FL cable look like they're spliced to strands 3 and 4. So that's pretty interesting. So if we go down and look at one of these strands, we will see strand 3. It's terminating on strand 1 at another site, and on the Z side, it's terminating at a fiber distribution panel. I can see the cable that's associated with this strand and then the strand number associated with this particular strand. And I can also see that this strand is consumed by a physical connection. So this physical connection going from Fresno to Hanford, if we can drill into that, we will see that this physical connection has two connection elements, and those connection elements, put them in order, are strand 1 from this FL01 cable and then strand 3 from that second cable. So if we go back and look at our diagram, we will see the FL cable. So that's strand 1, and you can see strand 1 is spliced to strand 3. So what I've done is I've created one physical connection, and that physical connection, FR FDF01A to HN FDF01C, has two sequences, two connection elements in it, and those connection elements are strands 1 and strands 3 off their respective cables. And again, if we go back into TNI, we can see that this physical connection has those two strands as part of it. This physical connection can then be used by logical connections if needed. So this physical connection can be consumed by a logical connection that's providing a higher level service on top of this that's utilizing these fiber strands. So that's a quick overview of the fiber optic cable and fiber strand capability that is new with the Washington DC release for TNI. Thank you. And wrapping up the features for the Telecom Network Inventory Washington DC release, we've also done a little bit of cleanup on our network inventory workspace, and we've done some re-architecture there, specifically adding some new capabilities for capacity management and also a new content tree navigation for your network inventory. Let's take a look at those. In the Washington, DC release of Telecom Network Inventory, we've made some changes to the Network Inventory workspace. Let's take a look at those changes. We are keeping the original homepage, and that has widgets associated with site totals, total numbers of sites in maintenance, network sites by status, quantities of equipment by categories, as well as network equipment by manufacturer and network equipment by state. Again, all of these widgets are configurable in our workspace. So this is not changing, nor is the original list view of the menu for network inventory workspace. So you'll still have your traditional list here of your sites, your equipment classes, and all of the other functions associated with network inventory workspace. What we've added are two new options on the left here. The first is this network viewer. So when you click on that, you'll be presented a blank canvas, and this will allow you to go in and to choose different network topologies. You can choose one or more network topologies to visualize. And so if I just add a couple of these here, I can get all this information. I can see how they interact with each other. I can click on nodes to get information about the devices in these topologies. So this is the first thing that we've done. We've added this topology viewer. The second thing we've done is we've added this inventory option here, and this has two tabs associated with it. The first tab is the overview, and on the overview screen, what you're getting is a network-wide view of various capacity management and quantity statistics of the devices in your network. So equipment by model, quantities by model, equipment by manufacturers. And then you've got rack unit availability, you've got capacity measurements to see how many racks are at threshold capacity, as well as slot and port availability. I can also click on this and go and pull in individual network sites to get a view of just the quantities associated with those sites. So in this case, I've added those three. You can see that it's changed my, my metrics and my widgets on my dashboard here. The second tab here is the inventory list, and the inventory list gives you a content tree view. And so starting at the location level, you can find your location and then drill down in those locations to find your network sites. So in this case, this is my Martin location. I can drill into there and see that I've got a central office under that location. And if I drill in, I can see the connections associated with the central office as well as the equipment. So if I click on my logical connections, I will see a list of all of the logical connections that originate or terminate in this network site, as well as physical connections and a list of all of the equipment. So these are the changes we've made to the network inventory workspace for the Washington, DC release. And that wraps up this overview of the Washington, DC release features for Telecom network inventory. Thank you for watching.